value. This is left over from 5.4. So let's say you have some function, and it's, I don't know, sometimes it's really low, and sometimes it's not, and sometimes it kind of is, and sometimes it's just sort of, who knows what that function does. And you would perhaps like to know what an average value of that function was. And sometimes it doesn't even necessarily make sense. What is an average value? If you had a discrete function, discrete function, it's got a certain number of numbers, that's it. It's not continuous. It's 1, and then it's 2. And it doesn't go between 1 and 2. It's not 2 and 1.5 or anything. Like, for example, your scores on your tests. You have, pretend you had, in a class, you had 10 grades, and that was it. They were all kind of the same. And, pretend you hadn't gotten there for 5 of them. So 5 of them are zeros, and you did great on the others, 5 of them are hundreds. Well, then you know your average is 50. Okay? And if it's a, see, they're going to be like that. If it was a discrete function, it's sort of, they're blocks, they're just, it's either there or it's not, and that's it. And in order to find your average, you just add them all up, and you divide by how many you had. Okay? So that idea is fairly straightforward. Well, if I drew this average, I would sort of fill some of those in, and they're all the same. Kind of like move them, you make a block. It's the same as if you had 10 of them that were 50. They're all the same height. Okay? That's what your average looks like when you think of it as a picture. Well, I kind of want to do that with this thing. So let's say I want to go from here to here, and I would like to figure out where the average value of this is. And if I'm thinking of it as a picture, I want to maybe smush down some of the high part so that they fill in the valleys. It's kind of hard to tell, but maybe, does that look about right? So like this one will fill in that one will fill in that one, and that will fill in that. Pretend it's right. Okay, work with me on this. So I'm going to call this high, I'm going to say that's the average value. However high that is. That right there. That length is my average value. And now my job is to figure out some way to get that. Okay? So, I have some approaches that I can work with because we agreed that it's the area under the curve sort of smushed down, right? So it's a true fact that area under the curve I know that that is equal to the integral from a to b of f of x dx. I know that. Okay. Well, it's also the case that the area under f of x should be the same as this box.
I'll call you in.
This box right here. You see that red box? And that's the same because I kind of melted down the high part, filled in the low part, and I want that to be the same. Okay? Well, that red box is equal to whatever my average value is. Because that's how high the box is. The average value is how high it is. Times, well, this guy right here, how far is that? Well, that's B take away A. Times that length. Okay? So average value times b minus a is the same thing as this integral. Alright, so anyway, the long and short of that is I can now solve for whatever this average value number will be. So all I have to do is divide by b minus a. So if I divide both sides by b minus a, I'm going to be able to say that the average value is equal to, well, instead of putting that as a fraction, it's kind of ugly as a fraction, I'm going to put it out front. 1 over b minus a times the integral from a to b of f of x dx. And that, friends and neighbors, is the formula for average value and how you get it. So if they ask you what is the average value of something that you have a continuous function for, you now have a way to find that out. So let's do an example problem. For example, I just happen to have one handy right here. A researcher models temperature. Okay, a researcher models temperature in degrees Celsius. T. That's all it's in degrees Celsius. During the time period from 6 a.m. to 6 p.m. By the function and the function is capital T little t. And it's equal to 3 minus 1/3 t minus 4 quantity squared for 0 less than or equal to t less than or equal to 12. Okay, so do you see that t is like going from 6 a.m. is t equal to 0? T is equal to 0, and 12 p.m. is t equal to 6 p.m. is t being 12. All right, so here's our function. It's a continuous function. And the question is, what is the average temperature in the city during the workday from 8 a.m. to 5 p.m.? So, what is the